Okay, this is substitution. Example 1. You have this, all right? All right. Solve for one of the variables in terms of the other one. Now I look at these two. This is a system of equations. And I look at this. This is already y. The coefficient in front of there is 1. That's what I'm looking for. I want to solve that for y. So what I'm going to do is take this equation here, and I'm going to take 3x minus y equals 4. And what I'm going to do is solve it for y. So that means that I have to eliminate the x. And by eliminating the x, I have to add the additive inverse to both sides. This is going to be minus 3x here. So this is going to give me minus y. My x term, or my variable term, always comes first. So it's going to be minus 3x plus 4. Now, I don't want minus y. So what I have to do is multiplication of minus 1. So I'm going to say minus 1 here, and I'm going to multiply each one of these terms by minus 1. This is going to give me y is equal to 3x. Now don't forget this, because this is where most people make their mistake. They do not multiply that by minus 1, because if I multiply that, I will get minus 4. Now, take this equation here for the value of x, substitute it into the opposite equation. Wherever there's a y, this has to go into the y value here. So I'm going to say 2x plus 5. Now instead of y, I'm going to put 3x minus 4 equals minus 10. Now use the distributive property on this, which will be 2x plus 15x minus 20 equals minus 10. Put the two terms, the like terms together, which gives me 17x minus 20 equals minus 10. Additive inverse on both sides gives me 17x. This becomes 0. I don't have to put 0 in there. And it gives me 10. Divide both sides by 17, and I get x is equal to 10 over 17. Leave it that way. Now, take that and put it into either equation and solve for y. So this one right here is 3x minus, now this is what's important. Notice where I put the minus sign. I put it outside because that's minus 1 there, minus 1 there. And that's equal to 4. Now, this gives me 3x minus 10 over 17 is equal to 4. This is the hard part. Fractions. Now I'm going to add 10 over 17 to this side and 10 over 17 to that side. That gives me 3x. I don't want that. I put it in the wrong place. Go back. That's all wrong there. Okay? The x value is 10 over 17. So I'm going to say 2 times 10 over 17. Disregard what I did there. Plus 5y equals minus 10. This is going to give me 20 over 17 plus 5y is equal to minus 10. Again, fractions. I am going to subtract 20 over 17. And on this side, I'm going to subtract 20 over 17. Now, this is going to give me 5y is equal to minus 10 minus 20 over 17. Common denominator, which is going to be 17 because this is 1. I have to find the common denominator between the two. 5y is equal to, if I multiply 10 times that, is going to give me minus 170 over 17 minus 20 over 17. which then gives me 5y is equal to minus 190 over 17. Now, if I divide by 5, this is what's difficult. Y is equal to, and this is going to come out to be minus 190 over 17 times 1 over 5. Multiplicative inverse right there. Okay, now y is equal to 5 goes into 190, and it's going to be what, 3, and this is going to give me 15. That's going to be 38, and this is going to be 38 over 17, and it's minus. So that's my two values of x and y. This is going to give me 10 over 17, and this one is minus 38 over 17. This is where the two lines will cross. Okay? That's example 1. Now what I'm going to do is example 2. This is an easy one. This is y equals 2x. And then I have 3x plus y equals 10. If I look at this, this is already solved for y in terms of x. So wherever there's a y, what I will insert into this one is going to be 2x. Notice I took this equation and substituted it into the opposite equation. So it's going to be 3x plus, instead of y, I'm going to put 2x equals 10. Put the like terms together. 5x equals 10. Divide both sides by 5, and I will get x is equal to 2. Now, put it into either equation. I will put it into this one, because y now is equal to 2 instead of x. I put 2. Notice how I put that in parentheses, because it's x that I'm inserting in for the 2. So this gives me y is equal to 4. My ordered pair is 2 and 4. This is where the lines will intersect. Now, to check it, I will take the 2 and put it over here for the x. I will take the 4, put it up here for the y. 2 times 2 is 4, is equal to 4. That works. Take it into this one. 3 times 2 is equal to 6 plus 4 equals 10. So it does work. Now, if you really want to check it, do it this way. Now, if I take this one right here, x, y, this is intercepts. Now, where x is 0, I will find the value of y. So when x is 0, y is 0. Now, if I say y is 0, okay, now y is equal to 2x, that's going to give me 0, which means that both points are here. I have to draw that line a different way. This tells me that it's going to cross here. If I use the slope-intercept form, that y is equal to 2x plus 0, crosses at 0, my slope, which is 2, which means that I go up 2 and to the right 1. My line will go through like that. Now, do the same thing with the bottom one. X, y. Now, if I put 0 in for x, 0 in for y, that's where they cross. This one was the hard one because the intercepts were both at 0, 0. So I had to use a different form, which is the slope-intercept form for this line here. This one, if x is 0, y is going to be 10. If y is 0, we have 3x plus 0 equals 10. 3x equals 10. X is equal to 10 over 3. Okay, so this is going to be 10 over 3. Now, if I take those 2 points and I say when x is 0, y is 10. All right, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right there. And the other one, when y is 0, which means that it goes all along this line here, at x is going to be 3 1/3. 1, 2, 3. I'll go out there 4, and I'll put that in there. Now, if I draw those lines, here is my other graph going up this way. And if I look right here, I'm going to come out to real close to where I want to be, which is going to be x is 2 and y is 4. If you have any questions, please contact me. Now, the other way I do that, I showed you the other way where I took the values here, which is 2 and 4, and put them into both equations, and it will solve the equations, making the right-hand member and the left-hand member the same. That's one way of checking. This way is graphing. That's another way of checking to make sure you have the right points. Thank you. Questions? Email me. I will be happy to answer any questions. Thank you.